Uh, Good morning, all my dear students. Sorry, good afternoon, all my dear students. Uh, Very less students are present. Only 53 students up to now. It's okay, fine. So today we will start the new chapter. So in the last lecture, I was completed unit number 7. Okay. Here I have to share my screen. Let's come to the syllabus. Dear all students, in the section 2, first section successfully we are already completed long back, and in the section 2 we completed interrupts chapter, unit number 5 interrupts. Unit number 6 we covered programmable peripheral interface 8255, and in the unit number 7 also we covered NDP 8087, that is numeric data processor 8087, also we covered in the last lecture. So up to now we covered all these many units. Unit number 1 to 7 we covered as per prescribed syllabus from PH University Sonapur. So anything, today I have to give you a chance of the unit number 7, whatever we covered in last lecture. Is there any doubts? Please let them, we will discuss. Otherwise, what I will do, I have to move to last unit. Only one unit is remaining. Only one unit is remaining in the theory part. That one we are going to cover it. And in the last lab session also, you done the displaying string and reverse of string. So don't worry, I will repeat you this program number 10. I will repeat you this week on Thursday. Someone they are not facing a problems and someone they are not getting output, so I will repeat it. So once I completed almost some of them they are executed, many of them they are executed, only few students they are waiting for that. So 1 to 10th program we have to cover in the lab session, and 1 to 7th units we have to cover in the theory sessions. So all the dear students, you will go through all the units whatever I covered and follow the notes whatever I provided. After that, if you have any doubts or any difficulties or any facing problems, so please make a note it, list out it, and transfer to me and get the solutions. Okay. Even single sentence or single word also you don't have a keep doubts with you. That is our main aim. Only the thing is left, unit number 8 for the theory part and the program number 12 and 11 for the practical session. If we cover these two program and this unit number 10, unit number 8, it means 100% syllabus should be going to cover. So in this week, almost I have to cover this unit, unit number 8, that is last unit. And in next week, I have to cover these two programs of the labs along with 10th program demo. Again, repetition of 10th program we have to cover. Almost in the month of February 10, within the month of February 10, we have to complete 100% syllabus of your batch. Okay. So now I will start the unit number 8. So in the unit number 8, just within a 5 minutes, I will give you a brief idea about previous units, how the connectivity is happened in the microprocessor from unit number 1 to unit number 8. So here just I have to check, am I audible? My screen is visible to everyone, please.
Yes, sir.
Okay. Okay, fine. So here, dear all students, just within 5 minutes, I'll repetition of all the units, whatever we covered. In the unit number 1, we covered introduction to microprocessor. In that, we studied 8085 microprocessor architecture, pin diagram, features. These things we have to study it along with microprocessor definitions and system bus. In the unit number 2, we studied architecture of 8086 microprocessor and machine level languages we studied. In that, addressing modes, instruction execution timings we have studied. Next, in the unit number 3, we studied all the instructions, that is assembly language programming instructions we studied. So that assembler instruction format, 8086 instruction and directives also we studied in the unit number 3. Mainly 72, 75 instructions we have to study for the helping for execution of the program. And in the unit number 4, we studied system bus architecture. In that, we studied mainly two concepts of configuration, that is minimum mode configuration, maximum mode configuration, and also we studied system bus timing. So this is entire portion of section 1, first section of the syllabus. Okay, so just we have to study the working functionality from introduction to system bus. Okay, so in the section 2 onwards, we studied interrupts. In that interrupts, we studied maskable and non-maskable interrupts, hardware and software interrupts we studied. After that, whatever the solution is going to be solved by the maskable and non-maskable, we have to solve by it. And some more big problems are there. For those kind of problems, we have to use 8259 programmable interrupt controller and 8257 DMA controller we are used. So these two architecture, block diagram, explanation, working functionality, all those we have studied. After that, in the unit number 6, we studied 8255 of the block diagram, architecture, internal operations, and also modes of operations we studied in the 8255 microprocessor. And also in the unit number 7, we studied that communication interface between 8087 numeric data processor. 8087. This 8087 numeric data processor is mainly used for arithmetic operation purpose. Okay. Some of the arithmetic operations, for example, if any number is divided by 0 is equal to infinity, so infinity is computer will not understand. There is no key on the keyboard. Infinity, there is no infinity key, right? So still this problem is not solved by the computer. So those kind of problems, if occurs in the during the execution of program, that time we have to use 8087 NDP, that is numeric data processor. So this much we have to cover. So today I will start with the unit number 8. This is the last unit in your syllabus for this semester. In this unit number 8, again 3 microprocessor chip we have to study. Architecture of 3 microprocessor chip, those are nothing but 8086, 80 80286, 80386, and 80486. These 3 microprocessor chips, just we have to study architecture, block diagram, and mode of operations. Only we have to study mode of operations and block diagram, or we have to say architecture, we have to study in this unit number 8. What are those microprocessor chips? Those are 80286, 80386, and 80486. Okay. If these 3 chips architecture we studied, it means that your microprocessor syllabus is over. Okay. So for that, I have to prepare the notes. That notes is with you here. So this is the Okay, so this is the nodes for 80286 first architecture. So come to this microprocessor group. I will share these nodes. Okay, microprocessor A and B. So here I'll save these nodes of unit number 8. Uh, as fine. Yes. Okay, it is uploading. Just 1 or 2 seconds, you will get it. Okay, I think all of you got this microprocessor unit number 8 nodes. Okay, yes. So just we are going to study the architecture of 80286, 80386, 80486, series version of 234 of 8086. Okay, so these are some extra chips added to the 8086 microprocessor to solve almost all our problems. So, for example, nowadays your mobile is connected to many networks at a time. So, some almost all the mobiles are having dual SIM. Most probably, everyone is using dual SIM. Some mobiles they have to use 3 SIM, 4 SIM, right? So, if the number of users are increases, number of networks are increases, that time we have to use next version of 8086, that is 286, 386, and 486. Okay, so whenever the users the strength is more, the input and output going connections are more, that time 8086 is not enough. To solve of this overcome, we have to use 286, 386, and 486 along with 8086. So in that we will go to first one, 80286 architecture. So here before that, what we studied already, all the things we studied in the 8086 except only few features. Except only few features. Here I tell you, bus unit we have to study BU. Bus unit that is in the 8086. There are two execution unit, right? One is execution unit and one more is bus interface unit. That one we studied. What is that says? The bus unit in the device performs all the memory and input output devices, reads, writes, perfects, and the instruction bytes and control transfer of data to be processed and executed device such as 80287. Okay, and instruction unit also we studied. All the instructions, whatever we studied in the third unit, all are applicable to this one also, 286. So in this, the instruction unit fully decodes up to 3 prefetched instructions and it holds them in a queue. It holds them in a queue with the execution of unit access them. Okay. And execution unit also we studied in the architecture of 8086. What is there? In that there are general purpose registers are there. Okay. And A, B, C, D, right? Segments are there, code segment, data segment, stack segments, extra segments, and operating of all the real address modes with the 8086 register set is the same as that of 8086. 90% this is obeys all the 8086 characters, rules and regulations. Only few are extra in this. So address unit also we studied. In that, it computes the physical address that will be sent out to the memory, and the input and output by the bus interface unit or bus unit, that is the 80286 can operating in the real addresses mode, and the address unit computes addresses using a segment base and the offset. Okay, so what are the segment base and offset here? That is code segment, extra segment, data segment, and stack segment registers are used in hold the base addresses of the segments. Currently, these are in use. For that, the maximum physical address space in this mode of 80286 is 1 byte. That is 1 megabyte, not 1 byte. It is 1 megabyte, means 1 into 10 raised to 3 bytes. So for this 8086 operating, it is protected virtual mode address modes, and the address unit functions as a complete memory functional units. And here the address mode in the 8086 uses all 24 address lines to access microprocessor to 16 megabytes and physical memory. So in the protected mode, in it also provides up to a gigabyte virtual memory using the descriptor. Okay, so this is 8086. So in the 80286, that is pin configuration, here we have to use 24-bit normalized address bus in the 80286. So this is the pin diagram 80286. It is a pin diagram which is having again 40 pins. That is 8086 pins are there here. So in this pins, the 24-bit address bus allows at a time to the processor to access 16 megabytes of physical memory, and when the operating protected mode is present, so the memory hardware for the 80286 is set up as in odd bank and even bank way. Odd bank and even bank already studied, right? Odd and even. So in the even bank will be the enabled when A0 is low, and the odd bank will be the enabled when bus high enable is low. Bus high enable is going to be low. In that condition, the buffers are used on both the address bus and the data bus. And the status signals like S0, S1, and mm, memory and input output, that is decoded on the external 8288 bus controller. So to produce the control bus, that is read, write, and interrupt acknowledge for the signals. Okay. So and what are the pins we are using? Hold pins, hold acknowledgement, interrupt, interrupt acknowledgement, and ready signals and lock reset pins have some functionality is same in the 80286. Whatever these pins we have to use it in the 8086, those are same as in 80286 also. So this is the one pin configuration. So this is not for your syllabus, just for your kind information I have to mention here. Just you go through it. Okay, all the pins are there, 40 pins are present over here for the 80286 pin diagram of 80286 microprocessor. Okay, so in that, an external 8284 clock generator, 82286 clock that latch, and 828688, that is transmitter and receiver also we are used. So for the signal 80286 and synchronize reset and ready signals also. So for the processor extension request, that is pin will be the observed by a coprocessor to tell the 80286 to perform a data transfer to from to or from memory for the main function. So Whenever an 80286 gets around to do the transfer, the processor extension knowledge acknowledge the means processor extension acknowledge PEAK. AK means acknowledgement, E means extension, P means processor. Processor extension acknowledgement is generated. The signals to the co-processor and it know the data transfer has started. So the busy line and test one line, that busy is whenever the more signals are comes in a queue, that time it says busy. That time the test is going to be happen and cover it. Okay. So whenever the 80286 execute a wait instruction, and it will be remain wait for a loop until the finds busy signals. So why means if the busy signals is available in the queue, lot of inputs are there. So for that signal from co-processor, so it is a co-processor. 80286 is also one of the co-processor. That is high co-processor finds any error during the processing of 8086 of error. So that is error input of 80286. Okay. So this is the pin configuration. And here, uh, now I will show you that this is the, oh, okay, this is the architecture of 80286. Just how to turn it out. Yes, fine. So here you have to just observe that this is the architecture of 80286. So just you observe in this what are the new things are present compared to up to you studied before all the microprocessor chip. So just I remind you what are the microprocessor chips are studied up to now. First one is 8085, second one is 8086 we studied, and third one we studied 8259. Next we studied 8259, 8257, and 8255. 595755 also we have to study it. After that we studied 8087 also, extended of 8086. So all these microprocessor, whatever I remind you now, to compare these microprocessor with 80286, what are the new things are present over here? Almost 95% of all the pins are covered in 80286. It means that in the 80286, almost it's always the 8086 only, but only some few features are added into the 80286. Okay. So for that, address unit you studied, execution unit you studied. Again, that is physical unit is there, segmentation basis you studied, offset address you studied. Okay. So now again I will move to one by one. Here, whatever the data is there, that one we are going to given to the ALU, arithmetic and logical units of the controller, which is in the arithmetic and logical units is carried by the registers. So here the offset address is there, 16-bit data lines and 4-bit offset address. It becomes a 20 address lines. That offset address is there, and here this entire section, this entire upper section, we call it as address unit. See, I have to shaded showed in the shaded mark. This is the address unit, and the lower one, this one is the execution unit. So entire execution is happened in the ALU, and entire address unit is happened in the offset address along with the physical segmentations, that is limitation of bases. Okay. So from that, so here this is the execution unit. Here it is a setting the address unit. From the offset address, the data is get into be added to the control unit through the ALU, that is arithmetic and logical unit. So the segmentation basis, which is containing stack segment, code segment, base segment, data segments, right? So those segments, and that output is given to address latches and derives. Okay. So that address latches and drives, which is A23 to A0, totally 24 bits, right? This 80286 is 24 bits. So that is A0 to A23 with the bus high enable and memory input and output. That is with this output. So and perfect prefetcher with the processor extension interface PEI or processor extension acknowledgement with processor access extension request. And for the ready state, if the data is ready, that is come to the mode hold and hold acknowledgement. So here we are using the bus control. Why we are using bus control? There are two types. Okay, data bus, control bus, and data
System bus.
control bus. And one more is, anyone please,
System bus, sir.
system bus. Okay, so in this, all the buses are used for the address unit manipulation, that is ready to the signal with the hold. So from that bus controller, the two signals, selective lines, that is S0 and S1 with interrupt acknowledgement. And if it is local also, we have to use signal clock generator with the hold acknowledgement. Okay, and the data transfer and receiver here at the pin number data line 0 to data 16. Because of this data 0 to 16, we have to add it 4 offset address, then the data address is become a 20 in the 8086. But here we have to add it 8 offset lines, and the data address lines are become 24 A0 to A23. So here, and we have to use 6-byte prefetch queue with the bus init. So this entire portion we call it as bus init. That because all the buses are working here, and this entire process we say it is an instruction init. Totally entire this architecture we categorized it into 4 main section. One is execution section, this one, and this is address section or say address init, and this one we have to say bus init. I have to mention at the bottom, and in the last one we say it is a instruction init. IU, BU, EU, and AU, whatever I mentioned in previous all 4 sections. Okay, just to go through that explanations, whatever I covered. So here again we are using 3 decoded instruction queue and instructions decoder. Coder and decoder purpose we have to use it in the instruction init. So and the bus line error in that interrupts, that NMI means non-maskable interrupts. We have to use it at the execution side. So this is the architecture of 8086. By looking the diagram is too much having a blocks, but it is very easy. You have to make categorize it into 4 sections: address init, execution init, instruction init, bus init. All those I have to all those I have to mention here. First unit is there at the beginning, instruction unit is there, execution unit, and address unit. So only those I have to show you in the architecture. So please you have to carry with this. Okay. So the real address mode operations of 80286 now, uh, after the 80286 is reset, it starts executing in its real address mode. So this mode is referred to as the real because the physical memory address are produced by directly adding on offset to a segment base. So very important this point, second one. And in this mode, the 80286 can address up to 1 megabytes can be easily transferred. That is physical memory, and the functions essentially as 8086. Whenever the operating in the real address mode, that of interrupt vector table of 808286 is located in the first 1 kilobyte of memory. It starts with 1 kilobyte of memory to 1 megabytes. Okay. So the 80286 has several additional built-in interrupt types. So these are nothing but the divider error exception, the single step interrupts, the non-maskable interrupts, the breakpoint interrupts, into detected overflow exception, bound range exceeded exception, and invalid opcode extension, processor extension, not available exception, and interrupt table limit too small, processor extension segment overrun interrupt, invalid task state segment, segment not present, stack segment overrun or not present, segment overrun exception, reserved the processor extension error interrupt, and reserved so the user defined. These are the some exceptions, some problems that is going to be solved by this 80286 microprocessor chip. So here in this 80286 processor, it separates interrupts into a two categories. What is interrupt? Everyone you know that interrupts are nothing but some problems or difficulties or abnormalities while doing the execution of programs. Okay. So the interrupts that asynchronous external events which affect the processor through the interrupt or non-maskable interrupt input are referred to as interrupts. So here maskable and non-maskable we have already studied in the interrupt units. So now we are going to study for exceptions. Whatever I listed here, all are exceptions only. In Java also you studied exception handling, right? So these are exceptions only. Interrupts we studied in the unit number 5. So what is exception is nothing but the type of interrupts is generated by some error condition that occurred during the execution of an instruction. That occurred during an execution of an instruction. So the software interrupts produced by the interrupt in instruction that are classified exceptions because they are synchronous with the processor. We don't say these are interrupts, we say these are the exceptions. Okay. So the exceptions are further divided into fault and trap fault. That's a fault sign, trap faults. It is an exception that are detected and signed before the faulty instruction is executed. So the segment not present exception is example for that fault. Okay. So these two examples we have to given for the exception, faults and trap signals. So for the trap, it is an exception which is reported after the instruction which caused in the execution executes, exception executes, and whatever we have to use it divided by zero exception and interrupt that interrupts are example of traps. So divided by zero is we have to use it for trap interrupt, and this fault interrupts if any data is missing or any data is not available, that time we are using this fault exception, and if divided by zero condition, that time we have to use trap exceptions. Okay, so these are the different exceptions what we studied, and these are the exceptions only the 80286 is handled. Other apart from the 80286, that is not possible in the 8086. That's what the 80286 externally we have to use it to the main processor 8086. Here the 8086 is the main processor, and 80286 all are co-processor that supporting processor to the main processor of 8086. So this is the exceptions. The exception list I have to made here. So if any type of errors comes, it will show this exception that is going to be solved by 80286. Okay. So next one, I'll move to the protected mode operation. How 80286 is acting as a protected mode. In this, if an 80286 based system is running an operating system such as Microsoft, which is used to protect mode. So protected mode means what? So for example, all of you using operating systems. So in that, just you have to compare the different operating system, that is Microsoft operating system, Windows, you have to with Fedora or Ubuntu. So Ubuntu and Fedora are, that is protected operating systems, but Windows are not protected because virus is going to be affected to the Windows. But that is not happen in Fedora or Ubuntu. Because why we have to say this means Ubuntu and Fedora are protected one, free from the virus. Okay, like that, the 80286 is also acts like that, free from any affected things from the externally. So in this, the switching of 8086 to protected mode, that is set to the protection enable bit in the machine status word, that is MSW, machine status word registered in 8086. So this is the machine status word. In that we have to use it task switch, emulate processor extension, my monitor processor extension, and protection enable. This is for the protection enable. This is for the monitor processor extension, and this is for emulate processor extension, and this is for task switch. Okay. So in this bits, the 1, 2, 3, bit number 1, 2, 3 of the MSW are for most part that is used for indicate whether the processor extension is present in the system or not. So this one we have to use it for that. And in the bit 0 at this state, that is protection enable of the MSW is to switch 80286 into protected mode. 1, 2, 3 are for these different way, and for 0 bit, that is for protected mode. To change the bits in the MSW, have to load the register word and the register or memory location and execute the load machine status word. After that, it becomes a LMSW, that is load machine status word instructions. So this is about the uh, machine status word. Next one we'll move to MMU, memory management unit. So how the protected way 80286 is going to be manage the memory. In that, the final step of get the 80286 operating fins, that is protected mode is executed and inter-segment jump to start. So for that, the main system program for jumping the necessary of flush into the instruction byte queues, because the protected mode in the functions is directly, that is memory management. So that switching of 80286 protected mode enables like, that is integrated memory management unit provide a virtual memory and protection. So that virtual memory and protection uses 14 pins for the selector of access to descriptor for the desired segment. Okay. So and in a table of descriptors, we have there's uh, okay, few lines of the main MU is going to be checks into there. So here, this is all about memory management and MSW means machine status word. So clear notes are given to here. Just you have to go in. So for that memory management to privilege the level of selector, high signals and higher than privileged levels is descriptor. So that causes the segment of to be allowed if not. So an exception is going to be generated if it is not or the error is causes. So this type of exception is going to be generated. So in the memory management unit also checks the P bit in the descriptor determine if the segment is present in the physical memory. If it is not, if the memory management unit generates a segment not present exception, that is not present exception is going to be generated by 80286. So in the memory access, it meets the privileged level test and the segment is present in the physical memory. So the memory management unit will add the 16-bit offset for this logical addresses. Here, 16-bit offset address is adding with the logical addresses to the 24-bit base address from the descriptor. So to produce the 24-bit physical address for the desired byte or a word in the segment. and one of the 8086 is switched into a protected board by the executing then LMSW instruction. So what is LMSW? The LMSW is nothing but load machine status word instruction. Okay, so this is about uh, memory management, exception, architecture of 80286. Only in the memory management easy and exception execution. That one is also used for this purpose. Okay. So next is the architecture explanation only. That one already we done it. Central processing in it, memory management in it, bus interface in it. Okay, all these already I explained. Just you go through it. So this is all about, and it indicates the signals of AD signals. So all the clocks, different kind of clocks also. Okay, we will go through these clocks. Yeah. So in the 80286, the signal descriptions are clock we are using D0 to D31 bits we are using 31 to A2 bits E0 to BE3 ADS ready VCC VSS BS16 hold acknowledgement busy error processor extension request interrupt non-maskable interrupt processor extension set that non-connections we have to use it here. Okay. Yes, fine. This is all about second one. Okay. So dear all students, that is about 80386. So 80386, I have to take it in the next lecture. So what you will do now, dear all students, so clear printed notes I provided to you uh, from this 1 o'clock. Now it's become a 1 o'clock, right? 1 to 2 o'clock, 1 to 2 o'clock. Just to go through these notes, whatever I covered today about architecture of 80286 and exceptions and memory management in it. So these three topics you have to study. Still, you have 1 hour time. Take this study hour. All of you take the study hour and go through it. Whatever I covered for 80286. Okay. So please now your study hour will starts from 1 o'clock up to 2 o'clock. And along with the study, please make a note down of some points and discuss with me. Okay. Thank you all. Please you start study about this 1 hour. So one thing, all of you listen. Still you have 1 more month. Okay, and only this one unit is remaining in the theory part, and 2 programs are remaining in the lab session. That one also we will cover it in within 10 days. After that, we will start revision of all the models. Again, I will do revision and some more MCQ questions I want to give you. So MCQ questions also I will prepare and I will give you after this unit. So still we have a lot of time. We don't have a hurry up. So slowly we have to cover this unit number 8. Okay. So take this 1 hour study hour up to 2 o'clock. Don't go log out anyone. Just to go through these notes. That very well defined notes are I have to provided you. Please don't ignore it. You have to refer seriously. Thank you.